So on your quizzes, I'm not going to be very strict about the way you answer with justification statements. But on your test, I will be more strict, okay? If you're asked to justify or explain an answer, you need to follow this kind of procedure. You need to have like an intro statement, which is the statement that will show me that you know what you're looking to find. You know what you're looking for. It is a, hey, I know what I'm talking about. This is how I'm going to get my answer. Then you could provide your answer. You can't just provide your answer, and this intro statement needs to be, hold on, Miss Ballard. Okay, you're good. It needs to kind of come from the definitions that we've used. Throughout the course. Example, if I ask you to find when a function is, let's say, increasing. And maybe I give you the graph of f prime or something. Okay? Let's say I gave you the graph of f prime. And it looks like this. Your intro statement should be, a function is increasing when its derivative is positive. Okay? Then you could say this occurs from 0 to 2, given this is the graph of f prime. And you're done. This is completely satisfactory for a justification of this problem. What you can't do is say a function is increasing if the graph is above the x-axis. That doesn't tell me anything. Besides, you got lucky that you were given the graph of f and not the graph, given the graph of f prime, not the graph of f. Okay, so you don't state, the trick that you know. You have to state the actual thing that we need to find. Okay, an original function will increase when its derivative is positive. This occurs in this situation from 0 to 2. Done. Some other things that could be asked of you, like when is something concave down? Your first statement should be, I know a function is concave down when its second derivative is negative. Then you might have to provide a situation, say if we are looking at this graph again. F double prime equals the tangent slopes or the derivatives of f prime. And the tangent slopes of f prime are negative from 1 to infinity, or when x is greater than 1. And that would be satisfactory if I gave you the graph of f prime and asked you when is f concave down. Okay, you could say f double prime equals the tangent slopes of f prime or something like that, whatever. Any questions so far? All right. More things you might have to justify. When a function has a relative max, your intro statement should say to the effect of, a function will have a relative max when its derivative changes sign from positive to negative. Now, do you have to also provide the link with the derivative being positive, meaning the original function is increasing? No, we don't have to worry about that. If you just go f prime changes sign from positive to negative, boom, f has a relative max. I know you know what you're talking about. If you want to be very, very thorough, you could say when f prime is positive, f is increasing. When f prime is negative, f is decreasing. Maybe that's like at the beginning, maybe. Because you don't have to say that though. Yeah.
If you're using a theorem, do you have to define the theorem?
No, we're not really using theorems here. We're just using kind of facts. They're I guess they are considered theorems, but this is us defining the theorem that we're talking about. There's no like by the first derivative rule or the whatever. We don't have to worry about that, thankfully. Relative min, when we change sign from negative to positive. Inflection points. Inflection point happens when the second derivative changes sign. If you want to include a statement that the second derivative determines the concavity of the original function or helps us determine the concavity, then that works. Certain questions like when is an object going to the left? You should say, and if they ask to explain your reasoning, all you need to do is include a statement saying that an object is going to the left when its velocity is negative. If you include that statement, that is proper justification that will go with an answer, whatever your answer is, whatever your interval is. If you have a question on speed, and you undoubtedly will have a question about speed on your test, because we just had an entire lesson and homework which had all these speed questions. If you're asked to justify when object speed is increasing, you should be talking about the signs of velocity and acceleration. You should say and include a statement, a speed of an object is increasing when the signs of velocity and acceleration are the same. If you include that statement with your answer, that is proper justification. Speed decreasing, of course, the signs would be opposite. Now, let's remember certain things. It was part of the last lesson about when something other than our original function f is increasing. So let's say I ask you a question, and this went with your last homework problem you had in your packet. It was like statement 1 of the last homework problem. It said, when is the velocity, or between 3 and 4.5, is the velocity decreasing? So maybe I'll change this to decreasing. Well, we should remember that velocity or something is decreasing when its derivative is negative. So I should have said velocity is going to be decreasing when the derivative of velocity v prime, which equals a, is negative. That's when something is decreasing, when its derivative is negative. If I ask you when is the acceleration decreasing, it's when its derivative is negative. Just like how we say when is f increasing, when f prime is positive. If I change this from when is acceleration decreasing to when is the acceleration increasing, you could say that's when a prime is positive. And that would be your intro statement. You'd say something is increasing when its derivative is positive, or something is decreasing when its derivative is negative. Let's write that down. Okay? And that is justification statements. Questions?